Greetings, Earth enthusiasts. If you ever wondered about the incredible perspectives our planet has to offer from high above, you're in the right place. I am Dr. Clive Coetzee, and I'm thrilled to be your guide on this captivating journey into the world of remote sensing. Welcome. And please remember to like, subscribe to, and share this video. Thank you.
This tutorial, we will further explore the work that we did on a previous tutorial where we looked at the CO levels before COVID and during COVID. If you remember, we looked at our data sets, and within our data set, we searched via the search function for the CO2 tag. We found our database. We left click on our database. We get our database, and it gives a whole lot of information as per normal. We then left clicked on opening in Code Editor, and it opened in Code Editor. There was our basic code, and what we've then added to this code was a pre-COVID period and a during COVID period, to get to some images where we compared the two images, and we looked at the mean images of within those two periods. Remember, once you've got your basic code and you have worked on your basic code, you generated your images and statistics and so forth and so forth, remember to save it. Now, let's go to our save version. So on your left-hand side in the Earth engine under scripts, we now we search for our tutorial or our script. Remember, we saved it as tutorial 4 CO2. I simply just left click on that tutorial or on that name, and it will open the script as we saved it. Remember, there's our two images derived from our data set. Remember that unique identifier that relates to the data set itself. We have selected the band, which is the CO column, the density CO column. Remember, CO is molecules per square meter, and we filtered it for a specific date. In this case, our date is 1st of 2019 to the 6th of 6 months of 2019. So we classify that as our pre-COVID period. Then we've created another image generated from, again, the same band. And this time we've changed the date to 2021 January to 2021 June. So we call this our period, a COVID period. And then we can, if we want to, we can then copy this specific piece of code and we can generate a third image. Let's call it post-COVID. So let's say post. And I'm going to change the date to this year, January 23 to the 6th month of 2023. We just need to confirm that we're still in our data range as that's available within a data set. Let's go and have a look at the data set. It goes to the 11th. So therefore, we're still in our data range. We keep the visualization parameters the same for all three images. And then I've also included a couple of additional layers. But before we get to that, remember, I've changed the center, the map center, to my region of interest. And remember, we have our zoom properties. I've changed my zoom to level 10. Now, in this case, I've created additional images based on the statistic within that specific time frame. Remember, we can use the mean image in that specific time frame, or we can use the sum of the image, or we can do the medium of the image. So there's three different statistics. So in each case, I'm going to create a mean value, a medium value, and a sum value of the pre-COVID image, and I'm also going to create a mean value, a median value, and a sum value of my COVID period. And there I've just labeled it so that within the um, layers panel, you'll know which layer is which layer. Okay, so in this case, we are just including an additional image, in this case, a post-COVID image, and we are creating additional layers, and each layer is just using a different statistics. Because remember, within this period, in each of these periods, there may be multiple images. Because remember, we're working with the image collection. So in that period, let's say, for example, the 1st of January, the January 2019 to June 2019, there might be 6 or 7 images. So remember, if we don't classify, don't specify a statistic, it will simply present the first image in each of these ranges, these filter dates. So it's important to specify a statistic so that you get a representative image of that specific period. And again, you can use your normal statistics as you would in standard descriptive statistics. And once you're happy with this health, I've also have to include now our post period for each of these post COVID period. So I'm going to go there and I'm just going to change the date here so that it corresponds to the image. Remember, collection.post, collection.post. The names have to be exactly the same. So I'm just going to, and then I'm going to say post here, post, post there. And then I'm just going to copy this specific piece of code, and then I'm going to paste it in this one. And this becomes, the statistic obviously is sum. And then I'm also going to add it into my medium images. And I'm just going to call this medium, median. Okay, so now I've generated 3 images, an image pre-COVID, an image during COVID, and an image post-COVID. And then I have created 3 statistics for each of those images. A mean statistic for pre-COVID, COVID, post-COVID, a sum statistic for pre, during, and post, and also a median image for pre-COVID, during COVID, and post-COVID areas. I'm happy with what I have scripted here or coded here, and I simply click run. Now, given the size of and the number of images, this may take a while. So I have already run this code, and here is my images. Now, in this case, I didn't include the post. I only looked at the pre and the during COVID images. But I still had the mean, medium, sum, and sum. It took a while to run, but they're all now located in my layers panel. So now I can go compare them. So if I switch them off, let's look at the pre-mean value compared to the pre-sum value compared to the pre-medium value. Now you'll clearly see that the sum value is basically just one big red, because it basically adds up. So if there's 6 images, it will add the CO levels and just sum those 6 numbers. So it wouldn't generate a mean or a medium of the 6 values. It will just sum them. That's normal statistics. So therefore, the sum will always present it in much higher values than if you look at the median and the mean. So the sum values are good, but just bear in mind that the sum is what it says. It is the addition of the number of values equal to the number of images in that specific time period. So if we just then rather compare the mean and the median value, you'll see that there is definitely a difference. So if we go to the mean value, you'll see that the area in red here, which is typically over the equator and over the Congo area, if we look at the mean value and we look at the median value, you can see there's definitely a difference in that the mean presents a much larger area of higher CO levels than the mean value. If we now compare, let's say, the mean value during COVID and the mean value of the sum, again, just red, and the median value of the COVID during COVID, you'll see exactly the same effect, but you can clearly see how the red or the high CO levels just get smaller compared to when you look at it in a mean value. So if we now look at the mean pre-COVID level and the mean during COVID level, you'll see some shift again. So now we're looking at the pre-mean and the mean in the pre-COVID area time and the mean in the COVID period, and you can see again a shift from 2019 to 2021. So this gives you some indication of the use of the various different statistics in and how these statistics influence the ultimate image that you're going to derive. So again, if I choose I go to my inspector, I select a relevant region of interest. Roughly, this is my region of interest. I left click on that region of interest, and you'll see all the statistics will now appear on the side. And again, you can see here the difference between, if you look at the mean pre-COVID is 0.019. The sum of the pre-COVID, you can see is 3.20. So you can see there's quite a large difference. And if we then look at the median, it's 0.019. If we compare that with the mean, you can see it's a little bit higher, 0.0195 compared to the mean value of 0.193. If we look at the mean during COVID, you're looking at 0.0194, which is higher than the mean value pre-COVID for that specific. Remember, we're talking about a specific region of interest, the one that I've defined using the inspector. You can see the sum much higher, 3.2 versus 3.5. And then you can look interestingly at the median. Now, this is quite interesting in that the median pre-COVID level is 0.0195, where the median during the COVID is 0.0196, which is much lower. So you have a mean value, which indicates that the mean CO levels or pollution, whatever you want to call it, for my region of interest was actually higher than during the pre-period if you use the mean statistic. Same with the sum statistic. However, if you look at the median, then just the opposite. It indicates for my region of interest, the CO levels were actually less during the COVID than before the COVID. So that begs the question, what makes sense. So let's look at another area to see whether, and let's go for one of these high CO areas. So let's click on that specific region of interest, and let's see whether it's the same. You can see 0.051 versus 0.52, much higher, again higher. But look at the medium again, very interesting. The medium value again decreases from 0.0519 to 0.049. So in general, this gives the indication that the median statistics is it's a better representative statistic than using the sum or the mean. So in general, when I do my statistics, I use the median number rather than the mean or the sum, because of these sort of anomalies or interesting numbers that you get. So that's for this particular tutorial where we looked at um, creating additional or creating more um, images. In this case, we've created a post image. And uh, in this case, after we've run it, you can see the post images are now loaded in the um, layers panel as well. And then if we just open those once again, if we zoom out a little bit, but you'll see it will take quite a bit of time now for these images to load, simply because you're covering the whole world and there's quite a lot of these images that we want to display. But what we've basically demonstrated is how easy it is to create additional images just by manipulating the time frame. So you can create a time series of images, and by this and using different statistics, we can display these images in different shapes and forms. In general, using the mean image is a much better representative uh, than if we use the mean or the sum. So I hope you enjoyed this video, and stay tuned for more videos to follow on the wonderful world of remote sensing and Google Earth Engine.